In this video, we're going to talk about alkali metal and alkaline earth metal. So in group 1, those metals are called alkali metals. So you'll find that the first member will describe this one as first member. So first member in alkali metal is lithium, and then it will have sodium, potassium, rubidium, cesium, and francium. So all these, they are grouped as group 1 metal because you can refer to the electronic configurations. All of them, they should have 1 in the outermost shells. So they will have 1 outermost shell electrons. However, they have different electronic configurations because you'll find that lithium have 2 occupied shells, sodium have 3, and then potassium 4. Even though they have same number of outermost shell electron, but they have different electronic configurations. So very importantly, we know that we can only say that they have similar chemical properties. The reason because they have a different degree in the reactions, when we put them, into other reactants, But one other thing I want you to pay attention is about the atomic size. So you see that, the more occupied electron shells they have, the larger the atoms, So this one will be a larger atom, this one will be a smaller atom. So when we go down the group, we found that the atomic size will also be increased in the process, Group 1 metals, they are very reactive. So you'll find that, all of the elements, no matter it's lithium, sodium, potassium, when we put it, when we try to store it, we store in paraffin oil. So this one is also very important. This is the elements, to prevent them or to react, with the oxygen in the air, the water vapor, or the moisture in the air. So normally we'll store it in paraffin oil. Pay attention to spelling as well. And then the similarities of group 1 metals, for these metals, we imagine metals are very hard, but to your disappointment, group 1 metal, they are pretty soft. How soft is it? You can just cut it, can be cut, by knife, so it's just like this one, so just like butter, so they're soft metal, and not only this, they have low density. To compare it in water, it is much more lower density than water. So if you put it into the water, you'll find that the sodium can float, on the water. And not only this, they are very reactive metals. They need to be stored under paraffin oil, to prevent it from reacting with the oxygen and the moisture in the air. And because it will react with the water, when we react it with the water, they will give alkaline solutions and hydrogen. The reaction, it looked like this, but that will not be part of the exam. So when you put the sodium into water, they will form sodium hydroxide and hydrogen. You'll find that the atoms on both sides, they are not balanced. So in senior form, we'll learn a process called balancing equation. By doing so, you'll find that we have 2 Na here, 2 Na here, and in this one, we have 2 O. So you have 1 O and then 2 O here. And then we have 4 H here, then you have 2 H and then 2 H here. So this one, on the left-hand side, right-hand side, the atoms are balanced. And from here, we can see that, the solutions turn into sodium hydroxide, which is a common alkaline solutions. And also because of this, we call this elements, these type of metals, we call that alkaline metal, just simply because when we put them into the water, they will give alkaline solutions. And in the process, we also give out hydrogen. So on the top view, if you put a alkaline metal in the middle, say for example like this, the surface of the alkaline metal, they will give out a lot of bubbles. They may be all different directions. So therefore this alkali metal, it will just move in different direction, just like a propellant giving out in one end of the sodium, and then it will push it to the other end. So these bubbles will push the sodium move around on the surface vigorously. And finally, alkali metal can form ionic compound with non-metal. Say for example, the most common one is sodium react with non-metal chlorine, they will give sodium chloride. So this is an ionic compound. We also call this salt, but this is not the only one. Okay, we may have like potassium bromide. We can have like lithium iodide, okay, or lithium oxide, things like that. Okay, so with many different kind of ionic compound can be made from this alkaline metal. So the chemical properties, okay, chemical properties, if you remember, it means that in the process, new substance is formed. Okay, in the process, okay, the alkaline metal, it will convert themselves into other products. So the one that we're going to talk about today, it will be the reaction with water. So you'll find that, okay, all of these, they will react with water, okay, but they will have different degree. Okay, pay attention to that. Okay, they have different degree, and because of this, okay, we can only say that they have similar chemical properties. Okay, so pay attention. Okay, you can have a look up here. Okay, when we put them into the water, okay, all of them they will float, all of them they will melt, and all of them they will give out gas bubbles. Okay, but the rate of giving gas bubbles they will be different. Okay, say for example for lithiums, okay, they will produce gas steadily. Sodiums, okay, they will melt to form silvery ball and move quickly. If they move quickly, that means the gas will produce rapidly. Okay, while the potassiums, okay, they will also melt to silvery ball. They will move very, very quickly, and the gas produced will be very fast. And then some of them, they may even catch fire by themselves. So you find that, okay, the degree of reactions is increasing when you move down, when you go down the group. So the very important concept is reactivities of group 1 metal. They will increases down the group, okay. The lower in the group, okay, the more reactive it will be. So rubidium and cesium, you will see that, okay, more vigorous, okay, they will be even explosives. Okay, we're not going to do that, okay, in the lab, but you can check this QR code. Okay, so if you're using iPad, okay, so you can use your phones to check the QR code. If you're using the phone to watch it, you can just refer to the descriptions, okay, downstairs. Okay, I'll give you a link right there. So this is one of the interesting videos talking about the reactions of alkaline metals with water, and in that, okay, you can see the rubidium and cesium reaction as well. Okay, so basically I just want to remind you that, okay, when you go down the group, it will be more reactive, and rubidium and cesium, that will be explosive as well. Next, we're going to talk about alkaline earth metal, group 2, okay? So this is alkaline earth metal. Pay attention to the spelling. If you spell wrong, okay, no mark will be given. So these metals, okay, mainly that you can find them in the earth, okay? But they are not purely metals. They will be in earth with other elements to forming a compound, okay? So say, for example, one very typical one will be calcium, okay? You can find it in limestone. So say, for example, they are in the form of calcium carbonate, okay? So mainly, okay, beryllium, magnesium, calcium is more probably commonly asked in the questions, okay, in this case. So beryllium, magnesium, calcium, you find that all of them, they have the same number of outermost shell, but again, they have different electronic configuration because they have different number of occupied electron shells. So we can only say that they have similar chemical properties, and also because it have different number of outermost shells, okay, with the comparing to the alkaline metal, so therefore they have a different reactions or comparing with the alkaline metals. So for the similarities of group 2 elements, okay, you find that, okay, they also have low density, but the density of group 2 elements, they are less dense, okay, than the group 1 element. They're denser than the group 1 element. They are denser than the water. So when you put magnesium into the water, you'll find that they will sink. You put the calcium into the water, they will also sink. Okay, that will be one thing very different from group 1 elements, and they are less reactive than group 1 element, but still we consider them as reactive, okay, because they can react with the water, they can react with the acid, or things like that. They will react with water, but less vigorous than group 1. And remember that, okay, in the first videos, okay, 6.1, we did say that for the metal one, this is the most reactive metals. Okay, so this one is less reactive metals, but still it is reactive. Okay, so they react with the water, okay, but less vigorously, and they can also react with acid to form hydrogen. Then you may ask, okay, but group 1, can they react with the acid? Of course, yes, okay, they can. Group 1 can react with acid, but that will be explosive. No people, okay, going to put the sodium or potassium into the acid, okay, because the hydrogen generation will be very fast and it will be very explosive, okay, just like the others, okay. They also form ionic compound, say for example calcium chloride, magnesium oxide, things like that, okay. They can also form ionic compound. And for the chemical properties, okay, they react with water, but you'll find that not all of them can react, okay, because beryllium, okay, they will not react with water or steam because the reaction of it is very, very low, okay. But just like group 1 metals, when they move down the group, okay, the reactivity increases down the group. So the most reactive one will be radium, beryllium, these things, okay? But beryllium will be less reactive. So they don't react with water or steam. Magnesium, when you go down, okay, they have no reaction with cold water, but they react with steam. What is the difference between cold water and steam? Actually, water is liquid state, steam is gas state, okay? The only difference is steam, they have more energy. This one have less energy. So if some metals or some elements, okay, they're less reactive, you just put water, may not be good enough. But if you increase the temperature, you know that when you increase the temperature, the reaction rate will be faster. So when you have like steam to react with it, then magnesium can react, okay? And calcium, okay, because it's more reactive than magnesium. So this time we don't need steam. We can just use cold water will do. And strontium and barium, all of them, they are more reactive than calcium, magnesium. So you see that they can react with cold water vigorously or even more vigorously. So the important point here is the reactions with the reactivity of group 2 elements, they increases down the group. So to summarize, okay, group 1 elements, okay, we call that alkali metal. Group 2 is called alkaline earth metal. Remember 3 words. Okay, and then the spelling of alkaline will be longer. Similarities, okay, they were soft, reactive. Okay, they have to store in paraffin oil, and then they will form ionic compound with nonmetals. Okay, so these are the similarities and reactions of group 1 metals. Okay, they will increases down the group. Okay, so as the group 2 elements, okay, the group 2 elements, they are the same. And the similarities of alkaline earth metals comparing to the group 1 metals, okay, they are less dense. They are more denser than the alkaline metals, okay. They will sink in the water. And also, okay, they will be reactive, okay, but they are less reactive than group 1 metals. They can also, okay, I forgot to say one thing. When they add into the water, they also give out alkaline solutions. Say, for example, when we put calcium into the water, they will also give calcium hydroxide. Okay, so at this moment, maybe you don't know why the symbol it looks different here, okay, but don't bother it. You just need to recognize that it will also give hydroxide solutions. So therefore, it is also a kind of alkaline solution, okay? So that's all for group 1 and group 2 elements. Bye-bye.